Hello students, welcome to the first tutorial on projectile motion. In this tutorial, we're going to have a number of objectives. The first thing that we're going to look at is try to look at what a projectile is, so try to define it and then see what are the key concepts or generally what makes a projectile. And then later on, we're going to move on to the general concepts that you need to keep in mind when you're working out any projectile question. So these ideas are going to stretch through regardless of the type of projectile that you're looking at. So we're going to describe that a little bit later to look at what are some of the common questions that you might find that have to do with projectiles. So we're going to look at them diagrammatically and see what makes them different or what makes them special. And then after that, we're going to end by looking at some examples, a couple of examples really, on how to use the concepts that would have described to actually work out some questions on projectile. So we might do a couple of videos in this series just to demonstrate a wide range of problems that are possible under projectiles. Okay, now let's quickly move on to look at the first objective. What is a projectile? Well, a projectile is just an object which is moving in air, of course. But then, as it moves in air, there is one thing that has to be satisfied for this to be a projectile. So if you have an object that is thrown or released, and then it is moving in some direction. So if the only force acting on this object is that due to gravity or the weight, the only force acting on the object, if the only force is the weight, then such an object, the motion of it can be described in terms of projectiles. So what am I saying? If the force acting on an object that is moving in air is only the weight or the force due to gravity, then such an object or the motion of such an object can be described in terms of projectiles. So objects that are, or let's say these projectiles, in most cases, you would deal with them in such a way that they tend to possess some motion in the horizontal, but while they're doing that, they are either going up. So it's like an object has two things at the same time, motion in the vertical and motion in the X, such that in the end, the object tends to satisfy both, as in it gets to move in the horizontal and gets to move in the vertical. But then one thing quickly becomes evident. So now we've defined what a projectile is. It's basically any object that is, when thrown or released, the only force acting on it is that due to the force of gravity. Now we're looking at one thing. You throw an object up, it is going up, but then we're saying the only force acting on it is gravity. So that force due to gravity, it will keep on pushing this force, this object down. So if you were to throw this object with some initial vertical velocity, so because the force is in the opposite direction, here we're assuming that you're throwing the object in that direction, an angle from the ground. What you notice is there is that force that blocks it from going up. So it keeps reducing the velocity in the vertical until when the velocity in the vertical becomes zero. So the point upon which the velocity in the vertical becomes zero, this is taken to be the maximum height. Okay, again, why does this velocity become zero? Because you have this vertical force that brings or that keeps on obstructing the movement of this object going up. It would be different if gravity, if this force was not there. You would expect that if the force was not there, then most likely the object will continue moving unhindered in that same direction, of course, according to the first law of motion. Okay, now because of the presence of gravity, the object tends to reach a final height, a maximum height, at which the velocity in the vertical becomes zero. And then after that, it now starts to fall. Under what force? Again, it's the same gravity that is pushing the object down until when the object strikes the ground. So you can say this is the object going up, object going up, object when the velocity is zero at the maximum point. Now the object is coming down until when the object finally strikes the ground. So here we're saying that this is an object that starts off on the ground, goes up until when it reaches back to the ground. Okay, now how do we describe the motion of a projectile? In general, there are two things that you need to keep in mind, but basically they all start from the same thing. See, the motion that we have here is a little bit problematic. If you're trying to think about how you can work it out, it might look a little bit scary, but it is experimentally known to say that if you have a projectile that is moving in this direction, you can easily break it into its two parts. See, to make this such a motion, you have motion in the x-axis, and apart from this, you have motion in the vertical axis or in the y-axis. Now, the key concept we're going to use here is that you can actually work out these two motions separately, and then after that, relate them through the one thing that is common between them. So in other words, I'm saying, split this. See, there are only two things happening. If you look at it from the y-axis, the object just moves from the level ground. Let's say if this is the level ground, or from h is equals to 0. So it moves from h is equals to 0 to this point, the maximum height, to h is equals to h max. So in the y-axis, all that the object is doing is moving from that level ground, and it goes vertically up until when it reaches a point where its height is equals to that h max, that maximum height. What at that particular point, what do we know about this? We know to say that at the maximum height, the velocity at the maximum height is 0. And what else? After it reaches that maximum height, the object now starts falling down. So once it starts falling down, this is only in the vertical. So it goes up and it comes down to strike the ground. Now with this, since there is motion in the vertical, and remember, a projectile is an object when thrown or released, the only force acting is in the vertical, which is the force of gravity. So it means that there is going to be a downward acceleration. The weight will always go towards the center of the earth. If you're on the moon, of course, going to go towards the center of the moon, but most problems will pin you on earth. So gravity here will go towards the center of the earth. So gravity G, which is equal to 9.8. It is an acceleration, so it is meters per second squared. But for the most part, when working out these questions, I'm going to be taking up to be positive and down to be negative. So if up is positive, gravity, we're saying it will always point towards the earth, towards the center of the earth. So meaning at every point, gravity is going to be negative. It will always point downwards. So in other words, when the object is going up, it means that the starting velocity, the initial velocity is positive since the object is going up. The displacement it is covering, so the displacement, let's call the displacement h, you can even call it s really, it doesn't matter. The displacement h is an upward displacement since it is going up. But look at gravity. When the object is going up, gravity will still be pointing down, g. So okay, that's g. So because of this, this is going to be negative, this is going to be positive, this is going to be positive. How about when the object is coming down from that maximum height? When the object is coming down, gravity is still going down, meaning g is still negative. But how about the displacement? Well, now we're coming from that top part, coming downwards, meaning the displacement is now also pointing down, meaning in this case, our displacement is also negative. Now, how about the initial velocity? Or the initial velocity from the top part is just 0. So it really won't matter. But if you were at any point, it can be maybe even a final velocity, but a velocity as the object is going down, it is going to be a velocity that is directed downwards. And because of this, the velocity will also be negative. So this is when it is coming down. This is when the object is going up. Okay. Now, so this is just in the y-axis. The object gets to go up, gets to go down. And then this is these are the vectors, so we have to respect their directions. One last thing, see, gravity in this case is your acceleration that you're dealing with. And the equations of linear motion apply once we break it to say we're dealing with the y-axis on its own and the x-axis on its own. The equations of linear motion will apply, implying that we're going to have v is equals to u plus at, but this is all in the y-axis. So these are components of that velocity in the y-axis only. Okay. Now, apart from this equation, the next thing that we have is s squared, or s is equals to u t plus half at squared, and then lastly, v squared is equals to u squared plus 2as. So this is the equations that we have, but the acceleration here is due to gravity. So this is going to be g, this is g, and this is g. Here we're in the vertical. And one last thing that I just wanted to mention here is, if we were to go back to our diagram, what is the velocity in the y-axis? See, if the object is thrown up in this manner, so it means that the velocity in the y is at an angle. Let's do this somewhere this side. So if the object is projected with an initial velocity v, then what you have to keep in mind is, if the angle that you're given here is theta, then we can get the vertical component of this velocity, so which is this component this side, by relating it to the angle, and this is going to relate via sine. So the velocity in the y-axis, the y component of the velocity, as we saw when we did vectors earlier on, to be given as v sine the angle, meaning that when working out these equations, the starting velocity is the velocity the object is thrown with. So meaning in the y-axis, the initial velocity, which is this here, is going to be v sine 30. Even here, it's going to be the same, v sine 30. Even here, it's going to be the same, v sine 30. But of course, this is when it is going up. When it is now coming down from that top part, now the initial velocity is zero because it's coming from the top part. So in other words, I'm always going to break this into two parts when it comes to motion in the y-axis. I'm going to break it down into two parts. One, I'm going to work out the part where it is going up separately, and I'm going to look at the part where it is coming down separately, so that I get the time. I'll get the time for when it is going up. I'm going to label it T1, and I'll get the time for when it is coming down. I'm going to label it T2, and the total time of flight. The total time now, it's the time for going up and coming down combined. So the total time T will be equal to the sum T1 plus the time for coming down T2. So this is the part or the equation I'm going to use, or the concept I'm going to use to get the total time. Okay. Now, this is just in the y-axis. This is what is happening, and this is how I can account for it. I can easily get the displacement, the distance to the maximum height using this equation. If I know the initial velocity, u, the final velocity is 0, g is just at 9.8, it's going to be negative, and then s is the distance to the maximum height. So I can easily get it. And if I wanted to find the time it takes to go up to the maximum height, I know the final velocity at the maximum height in the vertical is going to be 0. This is going to be 0 at the maximum height. The initial velocity is the velocity it is thrown with. So if I know that one, I'll plug it there. This is 9.8, it's going to be negative. And then t is the time. I can easily get it using this. So depending on what they want me to find, these equations will come to my rescue. Okay. Now, what is happening in the x-axis? We've seen what is happening in the y-axis. Now, what is happening in the x-axis? Well, in the x-axis, the general definition of a projectile is it only has the force due to gravity as the only force acting on it. This kind of means in the x-axis, there is no force there. provided the question says there's no air resistance. Mostly they will say that, but even if they don't say it, it is implied that there's no air resistance in this case. If air resistance is there, the problem becomes a little bit more complicated. So for younger levels, we usually take it that there is no air resistance. And with that assumption, it means that in the x-axis, the acceleration is equal to 0. What this kind of means is the only equation you need to concern yourself in the x-axis is the definition of velocity. So velocity v is equal to the displacement divided by the time. So this is the only equation that we're going to use in the x-axis. Now, of course, apart from this, sometimes that displacement, since this is in the x-axis, this is the horizontal displacement. So remember, in the y-axis, it went up and then it came down. In the x-axis, it only moves horizontally from point A until when it strikes the ground at point B. So this is all that is happening in the x-axis. So this horizontal distance from A to B, sometimes it is described as the range. So some questions will ask you to say, find the range. They want you to find this horizontal distance. Okay, so if you were to simplify this equation, write it in simple terms, just using symbols. So of course, the equation just becomes velocity is equals to the range or the distance or the displacement divided by the time. So this is an equation used for average velocity or when the velocity is constant. And in the x-axis, we're saying there is no acceleration. And if there is no acceleration, then the velocity is going to be constant throughout. What does that mean? In terms of our projectile, what it means is that at every point, as it goes up, reaches the maximum height, starts coming down. At every point in the horizontal, the velocity never changes. The same velocity you start with, that initial velocity, it will be the same throughout. So look out for this. Sometimes they'll give this as a multiple choice question. The velocity in the horizontal will never change. It's the same. The initial velocity in the x is the same throughout. So while the velocity in the y-axis is being affected by gravity, the velocity in the x-axis will not, because gravity is only in the vertical. So at every point, even at the maximum height where the velocity in the vertical is 0, the velocity in the horizontal will still be that same velocity you've started with. Okay, now how do these relate? So in the x, we only have this equation. But then one thing that is true for both the x-axis and the y-axis, or the relationship between them, is time. See, as the projectile goes up, as it goes up to the maximum height and then comes back down, by the time it hits the ground, it doesn't reach the same point. If this is point A, it doesn't strike point A. Because of the presence of that velocity in the horizontal, by the time the projectile strikes the ground, in fact, it strikes the ground at point B. In other words, while it was going up and coming down, it was actually moving in the horizontal as well. In other words, what we're saying is the total time of flight for going up and coming down is actually the same time it would take the projectile to move straight away, just horizontally from A up to B. That's the same time. So this time we have here is the same time it takes in the y-axis to go up and down. So most questions will require you to find time in one axis. And then once you find time in one axis, get that value of time, use it in the other axis to find maybe something else that they really want you to find altogether. So that is how we're going to work out project question. Start in one axis, then find time there, then take the time, go to the other axis, and work out the problem that they actually want you to find. So this is the main concept that we're going to be using when working out projectiles. Okay, now having described that, the last thing that we just want to do is to describe some common questions that will be asked when it comes to projectiles. We're going to see how to work them out really, but for now, let's just look at them. So the first one that we drew earlier on, if this is the level ground, and then the projectile is thrown at an angle. What happens to it? So let's say with an initial velocity v, the projectile goes up, reaches the maximum height, and falls down. Now here, we're taking this part as the ground. So here it's like the projectile leaves the ground and strikes the ground on the same level. So here h at A is the same as the height at B. So the projectile hits the ground or strikes the ground at the same level. This is one case that we can deal with. It's one simple case, of course. When you have a case like this, it's usually easy to work out. Okay. Now, what other cases are there? Well, another case that you can be given is, let's look at something like this now. You can be told to say that this time a projectile is being hit from at some point above the ground. What happens? Well, the projectile is hit maybe to go up, but when it goes up, it doesn't only go up, it doesn't only come down to strike the ground or to the same level as before. In this case, it falls down all the way until it hits a ground that is some height lower than where it started from. So here, in most questions, when it's something like this, you will be told what this is. So they can say this is h. And then, so it depends really with what they want you to find here. But in this case, you will in most cases have to first get that extra height to the maximum height, that extra displacement. I can even label it x this time. So you need to get that. Why do you want to get that? So that you know the full height from the ground. See, sometimes the question can ask you to say, what's the maximum height measured from the level ground? Meaning they want you to get x plus h. But sometimes they'll say, what is the maximum height with respect to where the projectile was thrown from? Meaning they just want you to get x. So pay attention to the type of language that the question is using there. Okay, so this is one case. Now, the other case that you can also describe is a situation where initially the projectile is moving horizontally. So in this case, the projectile is moving horizontally, but then it is released. So once that happens, once it is released, the projectile starts to slowly move downwards because of that gravity, until when it strikes the ground at some point this side. So until when it strikes the ground somewhere there. So this is another projectile problem that we can look at as well, that we're going to really look at. There are many situations that you can have. These are just some of them. Now, of course, this third one here is the simple one among the three I've drawn right now. Why? Because overall, you only have the projectile going down. In other words, it is nothing like going up, coming down. This is only going down. So meaning working it out should be a little bit easier as compared to the first one where it has to go up and come down. Now let's look at them. Look at the first one. For the first one, it's that same situation we described earlier on. To get the time, you notice that you have time for going up, t1, and time for coming down, t2. But because it falls to the same level, the time for going up, t1, will be the same as the time for coming down, t2, because you have the same acceleration and it's going up to the same height as it has to come down. So the time for going up is the same as the time for coming down. So if you get the time for going up in the first calculation, you don't have to calculate the time for coming down. To get the total time t, just double that time for going up. This is going to give you the total time. This, of course, is only when it lands on the same level. Now, how about the second case, where it lands a little bit lower? To get the time, you have to do it all the way now. Get the time for going up. But this time around, when getting the second value of time, don't break it into three separate values to say, first you get the time for coming only up to there, label it t2, and then this t2 is going to be the same as t1. So let me just say t1 here, and then make a calculation up to here. Why I don't like this method is because to get T2 here, you're going to end up with a quadratic equation, which I feel kind of, you really don't want to work with quadratic equation unless when you just have to. So this method, I don't prefer it, so I won't recommend it. Instead, to really finalize this, to get the total time, now work out this last bit as the time it takes now to move from there all the way onto the ground, meaning the initial velocity becomes this one equal to 0. You don't really care about the final velocity. As long as you know the total displacement from that maximum height to the ground, which is the x plus the h, you can easily get the time t2 using the equation. That's v squared, is it? No, you don't really want to know that final velocity. So s is equals to ut plus half a t squared. The best thing about this equation is at the maximum height, the initial velocity will be 0, meaning this is going to simplify to give you this a t squared. But this s, remember, it's a sum of x and h. So you can even plug in x plus h here. And then this is supposed to give you half a t squared. But again, when you're working out with the gravities now, since you see that gravity is going down, but the displacement is also going down. This is negative, this is negative. So this term is going to be negative. This term is also going to be negative. The negative will just cancel out. And then the term is going to be positive. So in such a situation, even if you had forgotten that gravity has to be negative, and then you also forget that displacement has to be negative, you would still reach at the same answer. Why? Because they just need to have the same sign. So if you're going to give gravity a positive sign, then the displacement needs to have a positive sign. Why? Because they're both going in the same direction in the vectors, meaning they must have the same sign. Okay, so this is for that case. And then when it comes to the third case here, this is the simpler case where it is just going down. So to get the time, really, you just need to get T1 for coming down. Once you get that, there's nothing like getting T2. That's all. So the trick here is how you get time. Once you know how you get time, then relating it to the y-axis or to the other axis, the x-axis, is the same in every method. Once you have that time, the velocity is just equal to distance over time or displacement over time, meaning that the range, which is just the distance, is equals to the velocity in the x times the time. Okay, so this is what you'd use once you obtain your value of time. But of course, sometimes questions will give you what the range is, and then they want you to find something else. So again, we're going to look at an example that has to do with that. Okay, so these are some of the situations that we're going to encounter. We might do more examples which I haven't described here. Sometimes it might be that it is actually, instead of just moving horizontally, it can be that it is something which is moving from the top and it is projected like this. You're given this angle here, meaning that the initial velocity now will not be 0. It is going to have an initial velocity in the y-axis, and that is going to be given by v sine theta. So this, of course, we can work this one out as well. It doesn't change how we approach it. Finding time, you only need to find T1. So let's look at some examples. The first example, very easy. We're looking at something that falls to the same level. So how do we work it out? So first of all, again, we imagine the diagram. It goes up, it comes down, it's falling to the same level. So what do they want us to find? Total time of flight, because it is the same level. Again, all you need to do is find T1. Once you find T1, double it, you get T2. You get the total time, I mean. So in the vertical, of course, since we're given the initial velocity, that's 200, the angle, that is 35. So the velocity in the y-axis, so if I'm dealing with the y-axis, that's where I'm getting my time. So the velocity in the y-axis is v in y is equal to v sine 35. So again, when I substitute, that's 200 sine 35, working this one out. Of course, I can leave it like this, I can work it out, but let me leave it like this for now. Okay, so now to work out, to find the time up to the maximum height. So again, that's, since I know at the maximum height, the velocity will be equal to 0. the maximum height, the velocity is 0. So I have the final velocity is equal to the initial velocity plus the acceleration due to gravity times t. Doesn't matter whether I write just a or I write g there, it's 2. I just know I'm moving in the y. Acceleration is due to gravity. Final velocity, 0. Initial velocity is an upward velocity, positive. Downward acceleration, this is gravity, it's downward, so negative 9.8 t. And then from here, of course, the v is 200. I can move the 9.8 to the left-hand side. So that's positive 9.8 t equal to 200 sine 35. Divide both sides by 9.8. I have 200 sine 35 divided by 9.8. Work this one out to 3 significant figures. You get 11.7. So this is just the time for going up. So this is just up to that point. So it's like I've just obtained time for going up the first part, t1. To get the total time, I know it will be the same value of time for coming down. This will be the same again, t1. So to get the total time, all I need to do is multiply the value I've found by 2. So the total time of flight will be equal to double the t1. And this is going to be, okay, I didn't label it as t1, so just say double the t. This is going to be 2 times 11.7. And this gives me 23.4 seconds. But again, I want to emphasize, this is only for when it falls to the same level. Okay. Now, next up, the next part of the question, what are they saying? So the next part, the question wants us to find what here? So they want us to find what is the range of the projectile. So we've obtained what the time is. Now they want us to find the range. So for the range, we're going in the x-axis. So we need to find the horizontal velocity, which is this velocity. So in the x-axis, the velocity in the x, v in x, is just v itself. And then this is now cos 35. So v itself is 200. And then this is cos 35. So this is the velocity in the x-axis. So to find the range, which is the horizontal distance, I move to the x-axis. And as we saw, the velocity in the x-axis being x is equal to 200 cos 35. But because again, this is a projectile, the only force is in the y-axis, meaning the only acceleration is in the y-axis. There is no acceleration in the x. It means that I have the velocity is equal to the displacement over the time. So that is displacement, which is my range, divided by the total time of flight. Okay, so my velocity in the x is that 200 cos 35. That is my velocity in the x. And then apart from this, my displacement is my range. My time is the value I found, the total time I found it from the y-axis, that 23.4. So from here, we can then cross multiply. I now have 23.4 multiplying 200 multiplying cos 35. This is what gives me the range. So from here, when I make the multiplication, I can just, when I do this, 23.4 multiplying 200 cos 35, what I get is 3. So I get 3,833.6 meters. This is what gives me my range. So when I rewrite this, starting with range, what I'm getting now is to 3 significant figures. I can write this as 3.83 kilometers. So this becomes my range. So this was very easy, very straightforward. Now, what if you had the same question, but now you are told to say that the projectile lands at a height or at a position lower than where it was thrown from. So we have a situation where this projectile is fired to go up and then comes down, but surpasses that level to fall in a valley a little bit lower in height. So it's like it is thrown from some height and then it falls somewhere far, but lower in position. So let's say somewhere there. So the first thing that they do is they actually tell you how low it falls. So sometimes they'll ask you maybe to even find the same thing. But here they're telling us, say that it falls 300 meters lower from where it is projected. So this is the other case that we described, possible for projectiles. So what we need to do here is to find the time for going up, T1. Apart from this, we need to find the extra height it goes, X. And then we already know the one from where it is thrown to the level ground. This is the 300. So when we add the 300 and the X, we get the full displacement from the ground, from the valley to the maximum height. Okay, so once we obtain this, we can use this displacement from the level, from the valley to the maximum height to get the time T2. Okay, let's do it bit by bit. The first part, we already did it. So getting T1, of course. So in the y-axis. So I want to get the total time, of course. So we start in the y-axis. So the velocity in the y-axis, v in y, is equals to v sine 35. I'll be a little bit quick about this since we already did this. So to get the time t1, we have v is equals to u plus at. 0 is equals to 200 sine 35. Here it's the same as I did in the previous question. So it's because it's the same thing. I just added that extra bit, 9.8t. And then as well, t here comes out as we saw previously, 200 sine 35 divided by 9.8, which just gave us 11.7 seconds. This is T1, the time for going up. Now, next, we want to find the time for coming down. But to find the time for coming down, first, we want to find that extra height it goes. So the extra height, which we labeled here as X. What is the extra height that the projectile actually goes up with? And how do we get that? To get this extra height, so again, it is still a displacement in the y-axis. So we're still in the y-axis. So that extra height, we're going to use v squared. Why are we using this? Because we know the final velocity in up to where it goes. We also know the initial velocity. And we know what g is. We want to find that extra height it goes x. So the final velocity at the turning point is 0. The initial velocity was still in the y-axis. That's 200 sine 35. It's still positive. Plus 2 multiplying gravity is still pointing down. So that's still negative 9.8. And then we want to find what that x is. So we make x the subject of the formula. 2 by negative 9.8, we get negative 19.6. Move it to the right, left-hand side. We get 19.6x is equals to the square of 200 sine 35. Divide both sides by 19.6, you get x is equals to then when you perform the operation here, you get the extra height as that comes out at 671.4 meters. And just take it as 671 here. Just make sure you maintain some level of significance. Okay. So once you obtain this, once you get this extra bit of height that it goes through, so now you know to say, okay, the projectile actually goes an extra bit, which is 671, but it is initially thrown from a height 300 meters. So now you know the full displacement it has to fall down. The initial velocity u is 0. The displacement is a downward displacement, so it's negative. That's some 300 plus that 671 So you can even keep that 0.4 bit, or you can just use it to that part. Okay, so you know G is a downward value as well, negative 9.8. So using this information and the equation, S is equals to UT plus half AT squared, you can easily find what T2 is. So here you're getting T2. So the best thing about this equation is it doesn't concern itself with the final velocity. So meaning you don't need the final velocity here. So the full displacement, when you add the 300 and the 600, the 300 and 671, what you get is negative 9. That's 971 is equals to the initial velocity is 0 multiplied with the time to give 0 plus 1 over 2, negative 9.8, and then that's T2 squared. So half the 9.8, you get negative 971 equal to negative 4.9 T2 squared. So divide both sides by negative. You have 971 equal to 4.9 T squared. This is T2. Divide both sides by 4.9. Swap them. You get T2 squared is equals to 971 over 4.9. Square both sides. You get T2 is equals to the square root of 971 over 4.9. And when you do this, what you get is going to be 14.1 seconds. So this is the time it takes, the total time it takes to come down, covering this full length. It first covers the 671 meters coming down, then that extra 300 to fall down to the valley. The time it takes T2 is 14.1 seconds. Okay. Once we've obtained this, now we can get the total time. The total time will be the sum. Total time will be time for going up, T1, plus time for coming down, T2. Time for going up, we found that 11.7. Time for coming down, we just found 14.1. So if you add these two, the 14 and the 11, you get 25.8 as the total time for going up and coming down. So this is the total time of flight. Now, once we've obtained this, the next thing that we want to now obtain, okay, the next thing that we now want to obtain is the range, the second part of the question, the range. So the range are now in the x-axis. So in the x-axis again, no acceleration. So because there's no acceleration, the velocity is equal to the displacement divided by the time. So again, the displacement is the range. So we can swap them, cross multiply here, you get range is equal to the velocity in the x, that's 200 cos 35. Total time is 25.8 seconds. So if you multiply these two, you see that what you get is going to be 4226.8 meters, which can be written as 4.23 kilometers. So this is the horizontal distance that the object covers as it moves from that point to the point lower. Okay, so I hope you guys were able to keep track of this now. Okay, so for our next question, so yeah, I think that's where that one ends. For our next question, you guys can look at this one. It's working on the same kind of projectile really, but the difference is the information that we're given. Here we're given the horizontal distance that it is covered, and they want us to find the total time that it spends in air. And instead of asking us to find the range now, they want us to find the velocity with which it was projected. So it's more like they've given us the range, but now they want us to find the velocity it is thrown with. So it's more like what we've been doing, but now just a little bit backwards. So you start from the X, then after that you go to the Y. Previously we were starting with the Y, then going to the X. Now you have to start with the X, going to the Y. But it won't really matter, just follow the same steps. Okay, so this is going to be for our next session. Okay, all right, you guys. Hope you found this video helpful. If you did, leave a like, leave a comment, which Which parts did you find interesting? And let's see, you can try this question out and let's see what you find. So this is where we end the video. We'll see you guys in the next tutorial. This was your tutor.